Hello everyone, we are the group number 4 and now we're going to present our second advance. This project is about optimization of the process of packing and dispatching sacks on ballets using simulation in Biomar Ecuador. So our teams is by Christian Tomalo, Luis Olmedo, and Javier Moreta. So about our company background, well, this company is located in Guayaquil, to be exactly in Daule. The products that this company produce is aquaculture feed, exactly to shrimp food. The activities is basically manufacturing and selling these containers to many farms. So now about our Y definition, we can see that our Y definition is average tons loaded and dispatched per day. We can see that how we can get this variable. About our problem statement is that we can see that during the period that we take the data is for about 30 days. We can see that the average daily productivity reached just 38.2 tons per day, but this is 22% below the expected level, that this is 49 tons per day. The general objective in our project is basically to increase this productivity of the packaging and dispatch process in Biomar Ecuador, applying time series and simulation. We want to reduce this by 50 and 60%, trying to get the 22% in that already set. So for specific objectives, we want to analyze this behavior about the productivity, and we want to compare the first scenario in the final scenario, applying or all the things that we want to apply. Okay, so about our focus problem, that we just want to reduce this 22% until final the project.
This slide shows the dispatch flow of pallets full of sack. First, wagon start on pallets and move to the warehouse for temporarily stored. The pallets are transported to the loading dock, load onto the truck when we dispatch documents and the trucks leave the plant. In the hidden factory analysis, we identify activities that consume time but don't appear in the office capacity. For example, starting parallel, uh, due to uneven palletizing and pallets waiting for free forklift reduce the daily throughput and contribute to the 22 productivity gap. Restacking can add around 50 to 20 minutes per pallet group, and the iron pallets break the flow and unbalance the ship. This shows that a significant part of the loss isn't in the machine itself, but in how material is handled between operation. With the value string map, we visualize the complex packaging and dispatch process. We can where material and information flow smoothly and where there are quickness, rewards, and waiting times that indicate potential bottlenecks, except the pallets accumulation, dispatch confirmation, and work confirmation. This analysis with us a total lead time of about 13.2 hours, but only a fraction of the time is the truly value adding for the customer. Around 39% of the time is productivity, and the rest is non-value add or necessary but no value add. We confirm that is room in the program efficiency. To the break on the start, variability we stratified the data by worship. The morning shift from the 6 to 14 and the afternoon sweep from 14 to the 22. Conditions show that the staffing levels and through schedule difference between shifts to the factor as a direct influence on daily productivity. For each slide, we is measuring each variable to the span per sweep, the number to load, the average loading per truck, forking utilization, and revenue with obligation.
Okay, for the data collection plan, these data were taken during 30 consecutive operational days in the packaging and dispatch area, recorded by operators and verified by supervisors. This structure plan gives us consistent and traceable information, which becomes a reliable baseline for the simulation model. For our data collection plan, we define the what, where, when, and who for each variable. Besides, we have a histogram of tons dispatched per day, which shows in general that most days fall in a band below the 49-ton target, so the shortfall fall is systematic, not just a few bad days. Okay. For the data reliability, we apply the Shapiro-Wilk normality test and probability plots for the key variables, like morning tons, loading time, forklift utilization, and arrival compliance. Overall, the patterns are close to the reference line and the p-values are acceptable. For the process stability, we have some control charts which shows that the process is statistically stable. The points stay within the control limits and there are no special causes patterns. At the same time, the average morning tons is low and the mean loading time is around 58 minutes. The forklift and truck charts shows a predictable pattern but high utilization, so the system has little extra capacity and the forklift can easily become a bottleneck when demand increases. For the process capacity analysis, you have the in the capability analysis for morning tons, the average is about 27 tons, and the capability indices are well below 1. In simple words, the morning shift is not capable of meeting the required tonnage. Okay, summarizing the measure phase, first, daily productivity is consistently below the target. Second, there is a hidden factor related mainly to waiting and restacking. And finally, the process is stable but not capable, especially in the morning shift. So these results provide solid and valid inputs, such as distributions of loading times, forklift utilization, and truck arrivals. To conclude this section, the measure phase allows us to transform raw operational data into a clear diagnosis of the packaging and dispatch process. So the next phases, analyze and improve, we will use this diagnosis to prioritize causes, redesign flows, and evaluate alternatives that helps Biomar move closer to its expected 49 tons per day.